Hi everyone, this is the new topic Ethernet, the rise of Ethernet. In the early days of networking, each vendor used its own proprietary methods of interconnecting network devices and networking protocols. If you bought equipment from different vendors, there was no guarantee that the equipment would work together. Equipment from one vendor may not communicate with equipment from another. As networks became more widespread, standards were developed that define rules by which network equipment from different vendors operate. Standards are benefit to networking in many ways. The first is facility design, and the next is simplify product development, promote competition, provide consistent interconnection, facilitate training, and provide more vendor choice for customers. There is no official local area network standard protocol, but over time, one technology, Ethernet, has become more common than the others. Ethernet protocol defines how data is formatted and how it's transmitted over the wired network. The Ethernet standard specifies protocols that operate at layer 1 and layer 2 of the OSI model. Ethernet has become a de facto standard, which means that it is the technology used by almost all wired local area networks, as shown in the figure. Okay. The next point is Ethernet evolution. The Institute, uh, the Institute of Electrical and Electronic Engineers of EAAA maintain the network standard, including Ethernet and wireless standard. EAAA committees are responsible for approving and maintaining the standard for connections, media requirements, and communication protocols. Each technology standard is assigned a number that refers to the committee that is responsible for approving and maintaining the standard. The committee responsible for the Ethernet standard is 802.3. Since the creation of Ethernet in 1973, the standards have evolved for a specific, faster, and more flexible version of the technology. This ability for Ethernet to improve over time is one of the main reasons that it has become so popular. Each version of Ethernet has an associated standard. For example, 802.3 10 base and 100 base T represented the 100 megabits Ethernet using twisted pair cable standard. The standard notation translates as one 100 is the speed of in megabytes per second. Base stand for baseband transmission, and T standard for the type of cable, in this case twisted pair. Early versions of Ethernet were relatively slow at 10 megabytes per second. The latest versions of Ethernet operate at 10 gigabytes per second and more. Imagine how much faster these new versions are than the original Ethernet network. Drag the solder bar in the figure across the timeline to see how Ethernet standards have developed over the time. Okay, years standard and description and years 1995, 202, 2002, 2015, 2016, and the present. In the present in this video is 2016 to represent is 2.5G base T and 5G base T, 2.5 gigabyte and 5 gigabyte Ethernet over twisted pair. And we have a lab determine the MAC address of a host. In this lab, you will complete the following objectives. Determine the MAC address of a Windows computer on an Ethernet network using the ipconfig /all command. Analyze a MAC address to determine the manufacturer. Okay, lab determine the MAC address of a host. Addressing table. Device, interface, IP address, subnet mask. Objectives: determine the MAC address of a Windows computer on an Ethernet network using the ipconfig/alt command. Analyze a MAC address to determine the manufacturer. Background: every computer on an Ethernet local network has media access control (MAC) address that is poured into the network interface card (NIC). Computer MAC addresses are usually displayed as six sets of two hexadecimal numbers separated by dash or colons. Example, okay, the ipconfig/alt command display the computer MAC address. You may work individual or in teams. Require resource: PC running Windows 10 with at least one Ethernet network interface card NIC and connectivity to the Internet. Instruction: Part 1. Locating the MAC address on a computer. Okay, I open Packet Tracer. I work with Packet Tracer. And okay, I select this PC. I work with this PC. Okay, open and desktop tab, command prompt. Okay, instruction part 1. Locating the MAC address on a computer. In this part of the lab, you will determine the MAC address of a computer using the Windows ipconfig command. Step 1. Display information for the command ipconfig/alt. Right-click on the Start button and select Command Prompt. Enter the ipconfig/alt command at the command prompt. Step 2. Locate the MAC physical address in the output from the ipconfig/alt command. Use the table below to fill in the description of the Ethernet adapter and the physical MAC address. Okay, description physical. Type your answer here. Okay, locate the MAC physical. Okay, okay. Enter the command with ipconfig/alt. Okay, well, connectivity, physical address. This is the physical address of my PC in Packet Tracer. Description, physical address. Okay, I put here is this 0001.96.86.075C. Okay. Okay. And okay. 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 How many MAC addresses did you discover in your PC? Only one. Answer will vary depending on the setup of the PC. Part 2. Analyzing the parts of the MAC address. Every Ethernet network interface has a physical address assigned to a when its manufacturer. These addresses are 48 bits, 6 bytes long, and are written in hexadecimal notation. MAC addresses are made up of two parts. One part of the MAC address, the first 3 bytes, represent the vendor who manufactured the network interface. This part of the MAC is called the OUI, Organizationally Unique Identifier. Each vendor who wants to make and sell Ethernet network interface must register with the EAAA in order to be assigned an OUI. The second part of the address, the remaining 3 bytes, are the unique ID for the interface. All MAC addresses that begin with the same OUI must have unique values in the last 3 bytes. In this example, the physical MAC address for the Ethernet LAN interface is this, and manufacturer OUI is the first 3 bytes, and unique identifier for the interface is the last 3 bytes. Vendor name Dell Incorporated. Step 1. List MAC address discovered by you and your classmates in previous part. List the 3 bytes manufacturer OUI and the 3 bytes unique interface identifier. You will fill in the vendor name in the table below. And step 2. Look up the vendors who are the registered owners of the OUI that you listed in the table. Wireshark.org provides an easy-to-use lookup tool. At this link, use this tool or use the internet to search for other ways to identify an OUI. Use the information that you found to update the vendor column in the chart in step 1. How many different vendors did you discover? Okay. Why might a computer have more than one MAC address? A computer can have multiple NICs, including 2 or more Ethernet NICs and wireless NIC. The sample output from the ipconfig all command show previously had only one MAC address. Suppose the output was from a computer that also had wireless Ethernet capability. How might the output change? The screen will list information for all NICs enabled on the computer. Try connecting and disconnecting the network cable to your network adapter. Use the ipconfig/all again. What change do you see? Does the MAC address still display? Will the MAC address ever change? What are others name of the MAC address? Okay, go to the next topic, Ethernet frames. Ethernet encapsulation. This module starts with a discussion of Ethernet technology, including an explanation of MAC Sublayer and the Ethernet frame fields. Ethernet is one of two LAN technologies used today, with the others being wireless LANs (WLANs). Ethernet uses wired communication, includes twisted pair, fiber optic links, and coaxial cable. Ethernet operates in the data link layer and the physical layer. It's a family of networking technologies defined in the EAAA 802.2 and 802.3 standard. Ethernet supports data between bandwidth of the following: 10 megabytes per second, 100 megabytes per second, 1000 megabytes per second, or equivalent to 1 gigabyte per second, 10 gigabytes per second, 40 gigabytes per second, and 100 gigabytes per second. As shown in the figure, Ethernet standard define both the Layer 2 protocol and the Layer 1 technologies. Data link, LLC, and MAC 802.2 and 802.3. This is all Ethernet. Ethernet is defined by data link layer and physical layer protocol. Data link sublayer. EAAA 802 LAN-MAN protocols, including Ethernet, use the following to separate sublayers of the data link layer to operate. They are the Logical Link Control (LLC) and the Media Access Control (MAC), as shown in the figure. Recall that LLC and MAC have the following roles in the data link layer: Logical Link Control sublayer. This EAAA 800 2.2 sublayer communicates between the network software at the upper layers and the device hardware at the lower layers. It places information in the frame that identifies which network layer protocol is being used for the frame. This information allows multiple layers 3 protocols such as IPv4 and IPv6 to use the same network interface and media. MAC Sublayer Media Access Control. This sublayer is EAAA 800 2.3 or these other protocols is implemented in hardware and is responsible for data encapsulation and media access control. It provides data link layer addressing and is integrated with various physical layer technologies. Network data link is logical link control sublayer, yes, and logical link control. Okay, with this protocol and MAC Sublayer is with these protocols. MAC Sublayer. The MAC Sublayer is responsible for data encapsulation and accessing the media. Data encapsulation is EAAA 802.3. Data encapsulation includes the following: Ethernet frames. This is the internal structure of the Ethernet frame. Ethernet addressing. The Ethernet frame includes both a source and destination MAC address to deliver the Ethernet frame from Ethernet NIC to Ethernet NIC on the same LAN. Ethernet error detection. The Ethernet frame includes a frame check sequence (FCS) trailer used for errors detection. Accessing the media, as shown in the figure, the EAAA 800 2.3 MAC sublayer includes the specification for different Ethernet communication standards over various types of media including copper and fiber. Copper and fiber. Ethernet standard in the MAC sublayer is the same. And recall the legacy Ethernet using a bus topology or hubs is a shared half-duplex medium. Ethernet over a half-duplex medium uses a connection-based access method. Carrier sense multiply access collision detection (CSMACD). This ensures that only one device is transmitting at a time. CSMACD allows multiple devices to share the same half-duplex medium. Okay. Detecting a collision when more than one device attempts to transmit simultaneously. It also provides a backup algorithm for retransmission. Ethernet LANs today use switches that operate in full duplex. Full duplex communication with Ethernet switch do not require access control through CSMA/CD. Okay. Ethernet frame fields. The minimum Ethernet frame size is 64 bytes, and the expected maximum is 1518 bytes. These include all bytes from the destination MAC address field through the frame check sequence (FCS) field. The preamble field is not included when describing the size of the frame. Note: the frame size may be large if additional requirements are included, such as VLANs tag. VLANs tag is beyond the scope of this course. Any frame less than 64 bytes is considered a collision fragment or run frame and is automatically discarded by receiving station. Frames with more than 1500 bytes of data are considered jumbo or baby giant frames. If the size of a transmitted frame is less than the minimum or greater than the maximum, the receiving device drops the frame. Drop frames are likely to be the result of collision of others unwanted signals. They are considered invalid. Jumbo frames are usually supported by most fast Ethernet and Gigabit Ethernet switches switches, and NICs network interface card. The figure shown in each field in the Ethernet frame refer to the table for more information about the functions of each field. Okay, 8 bytes, preamble and SFD, 6 bytes, destination MAC address, source MAC address, type or length, data and FCS. Field and description, preamble and start frame delimited fields. The preamble, 7 bytes, and start frame delimited SFD, also called the start of frame 1 byte, describe field, are used for synchronization between the sending and receiving device. These first 8 bits are the frame are used to get the attention of the receiving nodes. Essentially, the first few bytes tell the receivers to get ready to receive a new frame. The next field is destination MAC address field. This 6 bytes field is the identifier for the intended recipient. As you will recall, this address is used by layer 2 to assist describe device in determining if a frame is addressing to them. The address is the frame is compared to the MAC address in the device. If there is a match, the device accepts the frame. Can be a unicast, multicast, or broadcast address. The source address field, MAC address field, the 6 bytes field identify the origination, NIC, or interface of the frame. The next is type of length. These 2 bytes field identify the upper layer protocol encapsulated in the Ethernet frame. Common values are in hexadecimal for IPv4, for IPv6, and for ARP address resolution protocol. You may also see this field referred to as Ethernet type, or length. The next field is data field. This field 86 to 1500 bytes contain the encapsulated data from a higher layer, which is a generic layer 3 PDU, or more commonly an IPv4 packet. All frame must be at least 64 bytes long. If a small packet is encapsulated, additional bits called a path are used to increase the size of the frame to this minimum size. And the frame check sequence field, the frame check sequence FCS field for bytes is used to detect errors in a frame. It uses a cycle redundancy check, CRF, cycle redundancy check, cycle redundancy check. The sending device includes the results of a CRC in the FCS field of the frame. The receiving device receives the frame and generates a CRC to look for errors. If the calculation match, no errors occur. Calculations that do not match are indication that the data has changed. Therefore, the frame is dropped. A change in the data could be the result of a disruption of the electrical signals that represented the bits. And check your understanding Ethernet frame. Which part of an Ethernet frame use a path to increase the frame field to less 64 bytes? That is data link. All frames must be at last or least 64 bytes long. Additional bits called a path are used to increase the size of small frames to minimum size. Question 2. Which part of Ethernet frame detect errors in the frame? Frame check sequence. The FCS field uses a cycle redundancy check to detect errors in the frame. Question 3. Which part of an Ethernet frame describes the high layer protocol that is encapsulated, that is Ethernet type? The Ethernet type fields identify the upper layer protocol that is encapsulated in the Ethernet frame. and which part of an Ethernet frame notify the receiver to get ready for a new frame. This is the preamble. The first few bytes of a preamble inform the receiver of a new frame, and which data link sublayer control the network interface through software drivers logical link control. Click which data link sublayer work with the upper layer to add application information for delivery of data to high level protocol that is link logical link control. Question 7. What is a function of a MAC sublayer? Control access to the media, check for errors in receiver bits, and use CSMA and CSMA-CA to support Ethernet technology. And we can see two labs. View capture traffic in Wireshark and use Wireshark to examine Ethernet frames. This lab I do with Packet Tracer. Okay, this is all for this. See you in the next one.